Hello and welcome to Tribetopper. I'm Sonal Gupta, and this channel is about increasing your understanding of physics. To clear your concepts, subscribe to our channel and click the bell icon for latest updated videos.
Video session, you are going to learn about radioactivity. So, what is radioactivity, or we also call it as radioactive decay? If it is a naturally occurring spontaneous phenomenon, so it happens naturally and on its own. Spontaneous means it happens on its own. Nobody initiates this reaction. So it is a naturally occurring spontaneous phenomenon where an unstable nucleus decays into a stable nucleus by the emission of combinations of alpha, beta, and gamma radiations, or we also call as alpha and beta particles. Like if you remember in chemistry, you have learned about the chemical reactions. So you know that the incomplete octet that is responsible for the electrons at the like the ones which have one electron or two electrons in the outermost shell, they give away that and become stable with a complete octet. But here the electrons do not participate. It is not at all an electronic or a chemical reaction. So in a nuclear reaction, you have the nuclei which is responsible. So the nuclei are unstable. They have either an extra number of neutrons or protons and they become unstable. And so they emit some of the particles called alpha, beta, and gamma particles and become stable nuclei. So that is radioactivity. So the definition I would read out once again. It is a naturally occurring spontaneous phenomenon where an unstable nucleus decays into a stable nucleus by the emission of combinations of alpha, beta, and gamma radiations. We must remember that the nucleus which decays is the parent nucleus, and the nucleus which we get as a product is called the daughter nucleus. For example, if uranium decays into thorium, then the uranium is the parent nucleus and the thorium we obtain is the daughter nucleus. Right? Now let's try to understand the cause of radioactivity. As I just said, it's the unstable nuclides which will participate in radioactivity. So, which are the stable nuclides first of all? Stable nuclides will be the ones which have equal number of neutrons and protons present. See, you know that within a nucleus there are neutrons and protons together. And because protons they repel each other, but at the same time the neutrons and protons, or protons and protons and neutrons, they attract each other with the strong nuclear force. So that's why they are all held together. But as long as this number of neutrons is equal to the number of protons, the ratio is constant. That's 1 is to 1. The nuclides are stable. So you can see this blue line, right? That indicates a straight line, linearity between the number of protons and the number of neutrons. But as your Z increases, some nuclei they have more neutrons than protons, or some nuclei may have more protons than neutrons. That gives rise to an instability of the radioactive of the nucleus. And now as soon as the nucleus becomes unstable, because if there are more protons there'll be a lot of repulsion going on, so it needs to get off extra protons. So to get rid of either extra protons or extra neutrons, it has to release some particles. It emits some particles depending on what it wants to get rid of. So accordingly, when it releases, it emits those alpha or beta particles, then that gives rise to the decay of the nucleus, and that is called the radioactive decay. So you have to understand the cause of radioactivity is the instability of the nucleus, which is caused by the greater neutron to proton ratio or greater proton to neutron ratio. As long as number of neutrons and protons are equal, they are very much safe and stable. So in the next few videos, you are going to understand that which type of decay, alpha, beta, gamma decay happens in which of the cases, like which instability or what type of particles are responsible for the alpha, beta decays. So in the next video session, you are going to learn about the alpha decay. Thank you for watching.